Okay, so let's take a look at the last part of math reasoning, which is going to be taking a look at puzzles and game theory. So, for our first investigation, it says Chris, a computer programmer, is designing a digital arcade app for the iPad. The game will have 10 levels of difficulty, with the first level being the easiest. At the first level, the object of the game is to drop the ball so that it lands at a predetermined exit marker by one of the four letters down at the bottom here: A, B, C, D, E, F, or G. An illustration of the draft of the first level is shown. So first, it says determine how many ways there are to get to each black dot and write the numbers over each black dot in the illustration. Well, if I'm dropping the ball, for this top one, there's only going to be one way that I can do that. It's just going to drop straight down. If I want to get to the one on the left-hand side, it has to drop straight down and can only go directly to the left. So there's actually only one way to get there as well. If I keep going along the left, then it's going to have to drop down and keep going straight left, so there's only one way to get to this one. Same thing on the right-hand side. Drop down, and it's going to go to the right, and I've only got one path to get there. Drop down, and go two to the right, and I've only got one path to get this one. Now the ones on the inside are slightly more complicated, because we can see that here we can drop down from the top, and it can go to the left, and then to the right to get there, or drop down from the top and it can go to the right and then to the left to get down there, which means that for this one, there's actually two ways we can get there. For the next one, on the next level, it can drop down, go to the left and one to the right. It can drop down, go one left, one right, and then one left. Or it can drop down, go one to the right, and then two to the left. There's actually three ways to get here. Now, if I'm looking at what kind of pattern is forming, well, I know that the ones that are going directly to the sides, there's only going to be one way to get to each of them, because it's just going to have to drop and go straight down to the left, or drop and go straight down to the right. As soon as it veers away from the sides, it can never actually move back up again to get to those points. Now, because this is symmetrical, at the 3 level, if I drop down to the 3, then this one is going to have the same thing. It's going to drop down, go one to the left and two to the right, drop down, go one right, one left, one right, or drop down, go two to the right, and then one to the left. And when I'm taking a look at this, well, this actually looks pretty similar to a pattern that we've already seen before, where if I look directly up, I can see that the two diagonals, if I add them together, it'll give me 2, or if I add the two diagonals above this together, it gives me 3. Two diagonals above this together, it also gives me 3. So this pattern should continue. That means that this would give me 4 if I add the 1 and the 3 together. This would give me 5. Because it's symmetrical, this would also be 4, and this would also be 5. On this level, in between the 4s, I have a 3 and a 3. There's going to be 6 ways to get there. And on the bottom level, the 4 and the 6 are going to give me 10. And this is also going to give me 10. Which means once I drop down to the very bottom, there's only one way to get to A, there's one way to get to G. If I add the 1 and the 5, there's 6 ways to get to B, there's also 6 ways to get to F. If I add the 5 and 10, there's going to be 15 and 15, and for the 10 and 10, there's 20 ways to get to the one that exists in the middle on the bottom. So, what's the pattern? Add the diagonals above. And because we looked at it and just looked at what pattern was forming, we would refer to this as inductive reasoning. We looked at some case examples, and then from the case examples found the pattern. So, if I use the strategy to put all of them, I already did that. And if we went all the way back to Lesson 1, Assignment 2, how does the explanation of the pattern compare? Well, they are both examples of Pascal's triangle. They're both the same mathematical pattern.